Yeah, hi, I'm Justine. I'm a data scientist at Austin Capital Data, and today I'm excited to share one of the demos that we've been working on. Actually, I really wish Henning had started his project a couple months ago so that I had it to use for my own project because it sounds really great. Yeah, so Cocktailgraph is a platform to facilitate the exploration of ingredients and recipes from a biochemical perspective. And it contains drink recipes from around the world, and this data space is enriched with biochemical data that's sourced from scientific literature. So let me first introduce myself and give a little bit of background about how I became interested in graphs as a member of the Gracken community. My background is actually in the life sciences. I'm a neurobiologist by training. I studied neurons that are important for taste and memory formation in fruit flies for my doctorate. So as a neuroscientist, we're interested in understanding how the brain works. And one aspect of this is understanding that there are connections between neurons and trying to understand how all of those connections work. And right now there's many large-scale efforts, including the Brain Initiative, that have a goal of creating a dynamic picture of the brain, showing how individual cells and complex neural circuits interact with each other in time and space. And that structure is really akin to that of a graph. And to understand that network is to understand all the nodes and edges. At some point, that analogy between brains and graphs breaks down, but what I'm trying to say is that a graph is a really cool way to organize many pieces of information. And anyways, that's enough about me. Let me tell you about cocktails and the graph that we've been working on. So in this talk, I'll mainly be focusing on the process of building the graph, from sourcing the data to writing schema to loading the data. And I'll show you a couple of examples of querying the graph as well, and a use case. So this is very much still a work in progress, and I hope that it'll be useful for those who are new to the Gracken world, as I was when I started on this project. And then finally, I'll wrap up with giving you a teaser of some future applications. I'll begin with the history of the cocktail. So there are unfortunately countless stories that report to detail exactly where the term cocktail comes from. And none of them are verifiable, so we'll most likely never know the true story. We do know, however, that the word cocktail began showing up in publications around the early 19th century. According to the OED, the earliest definition of the word appeared in May 1806 in an edition of the Balance and Columbian Repository, which was a Federalist newspaper in New York. And the editor wrote a lengthy answer to the question, what is a cocktail? His reply was, a cocktail, then, is a stimulating liquor composed of spirits of any kind, sugar, water, and bitters, and it is vulgarly called a bittered sling and is supposed to be an excellent electioneering potion, inasmuch as it renders the heart stout and bold, at the same time that it fuddles the head. It is said also to be of a great use to the Democratic candidate, because a person having swallowed a glass of it is ready to swallow anything else. This is mostly accurate, and back then, cocktail referred to a specific blend of alcohol, sugar, water, and bitters, and not to the wide range of mixed drinks as it does now. And if that blend of ingredients sounds familiar to anyone, well, it's the reason that we call an old-fashioned an old-fashioned. So what's in the cocktail graph? It's currently a collection of recipes, ingredients, and compounds. We also have data about food metabolites, linked health effects, as well as ratings that we plan to use to make predictions about the popularity of a recipe or make custom suggestions. Now, we're certainly not the first to think of AI-generated cocktails, nor will we be the last, but a really exciting aspect of Cocktailgraph is being able to integrate scientific literature and make suggestions and predictions based on that. There's a lot of literature out there, as I'm sure you know. Papers are published every day, lots and lots of them, and being able to make that information accessible to a broader audience is really important. So after a lot of Googling, I ended up settling on this website, the Cocktail Database, as a source for drink recipes. It has 604 cocktail recipes, 481 ingredients. And this is a pretty good amount of data to start with, and it's open source and it has an API, what's not to like. I also have my eyes on a couple of other sites that don't have an API, but others have successfully scraped data using Beautiful Soup. So what does the API do? The call pulls JSONs, and you can see the structure of a pina colada here. You can see that it has information about the glass, some instructions for how to make it, instructions in other languages sometimes, a link to a picture, and then ingredients as well as their amounts. For information about ingredients, I ended up choosing food database for the first iteration of this cocktail graph. It also has an API, but I didn't end up using that. Instead, it's available as a MySQL dump or as CSVs that you can download. This database provides information on both micronutrients and micronutrients, including things that give foods their flavor, color, taste, texture, and aroma. There's also information about composition as well as biochemical and physiological information. And all of these are obtained from the literature of references. Then there's data on each compound's name, its description, and has information about its structure, chemical class, physicochemical data, and presumptive health effects from published studies, as well as their concentrations in various foods. So now let's talk about the Gracken schema. The schema is the blueprint of the Gracken knowledge graph. I've also seen some people refer to it as an ontology, but whatever you call it, its purpose is to model a domain, which in this case is a cocktail. The schema defines a very specific, explicit, high-level structure of data that's enforced across the entire data set. And the way that it's structured makes it very intuitive for writing queries, which I'll talk about later. So in a schema, there are three main characters when building the story of a Gracken schema: entities, relations, and attributes. And I think the place where Gracken really shines is having these relations to describe edges in a graph. Let's take a look at a concrete example of these concepts by drilling down into a pina colada. In the cocktail graph, these are the entities. There's the cocktail, the ingredient, and the compound. In your schema, you first define these entities using a syntax like this. The cocktail is an entity, the ingredient is an entity, and the component is also an entity. Now, how are all of these entities connected together? These are the relations in the graph. The recipe relates the whole cocktail to the cocktail ingredient, and the composition relates the cocktail ingredient to the ingredient compounds. And that's exactly how you write it into your schema. The recipe is relation, which relates the whole cocktail to the ingredients, and composition is a relation that relates the whole ingredient to components. Next, we add in all the attributes. These are things like names, so the name of a cocktail like a pina colada, name of ingredients, rum, cocktail milk, or coconut milk, pineapple. Components like sucrose, water, citric acid, fructose, many others. Relationships can also have attributes, and in this case, these are the amounts of each ingredient in a recipe, like a shot or number of ounces, and the composition relation also has an attribute describing the contribution, the concentration of each chemical compound in each ingredient. So you write all of this information into the schema as well. For example, cocktail has a name, the recipe has an ingredient amount, and lastly, you declare all of these attributes and tell Gracken what type of data you're sending in. All these words are strings for me, and the attributes have numeric amounts, so I assigned them as doubles. So here you can see a graphical representation of the schema in Gracken database. For a relatively simple graph like this one, it's a really nice way to visualize and make sure that all of your relations and entities are what you're expecting, and it's a good way to check that your schema actually loaded. So to migrate all of the data, we used the Python client, and this was the clear choice for us since we're already using Python to clean and standardize our data sets. Henning talked about these problems earlier where there's a lot of work to go and standardize, so I spent a lot of time removing all the spaces, removing escape characters, things like this. And the process for migrating data using the Python client is nicely documented on the Gracken website. This is an example of a very simple insert query here. So you instantiate a client and open a session. This insert query just inserts an ingredient with a name from a dictionary. Then you create a transaction for reading and writing the data. And this query is just for the ingredients, but you do something similar for all of the entities, the attributes, and relations. So once the data has successfully inserted, you have the graph. Here again, I'm using Gracken Workspace to visualize a slice of the graph. This is only a fraction of all the entities that are displayed right here. And I know the text is pretty small, but don't worry about reading every node because there are unique IDs here which map to an entity. And you can see that even though this cocktail graph is quite small compared to some of the larger biological graphs that people are building out there, it already has a lot going on. So you can do a little bit of poking around in Workspace as well. If you zoom in on one of these nodes, for example, on this one, then you can find out more about it. So this is gin. Notice how it's central as an ingredient to several recipes. And you can also check out that it has an ingredient description on the right-hand side. So that's been inserted correctly. So this is the really interesting part of the project, right? You've built a graph and now you get to query it and hopefully learn something. So you can imagine a scenario where you might want to filter by ingredients. Maybe you don't like strawberries, or perhaps you're allergic to them. So you want to make sure that you're not ordering a drink that has strawberries. I mentioned earlier that the Gracken syntax for querying makes a lot of sense. So here you can see that syntax. You're matching something which has all of the characteristics, entities, attributes, and relations that we described in the pina colada earlier. So it must match a cocktail, which has a name. There's an ingredient, which has a name, strawberries. And the ingredients are related by a recipe through a relationship. So given all of these constraints, give me the names of the cocktails which have these characteristics. So you can see here, like the name of strawberry cocktails. Similarly, you can ask Gracken to tell me about this ingredient and give me the description. The syntax is largely similar, but here instead you're asking it to return the description. Again, you can also drill in and ask what composes a pineapple. So give me all of the compounds that are contained in a pineapple. And you can see that you can explore all these names. All of these have chemical structures attached to them, and there are common groups between different ingredients. So another interesting use case of the cocktail graph might be for someone who has a dietary restriction. For example, if you're following guidelines by the American Heart Association, then women should consume no more than 25 grams of sugar per day, which is actually pretty low by any measure. So assuming that I plan to follow that, and I want to leave a piece of chocolate, then that leaves me with about 10 grams of sugar to spare in a cocktail. So we can filter this data set by calculating an estimate of the total sugars in a drink and then filter a drink. So what you're looking at here is all of the cocktails which are plotted after dimensionality reduction using t-SNE. And it looks like there are some clusters, but it's hard to tell from the current form of the data set because all of the liquors and spirits are treated equally as any other ingredient. So you can see that each point is a cocktail and we've filtered by the total calculated sugar, and then the user can easily see which cocktails are suitable. This plot was generated with Bokeh, which allows for dynamic interactions, so you can actually zoom in and hover over each point to discover what the cocktail is as well. So that's kind of the exciting point where we're at with this project. And of course, there's still a lot to do and still a lot that can be done. There's always the goal of adding more data. This includes more recipes, ingredients, compounds, health effects data, and possibly other ontologies as well. And it's actually been quite hard to get a comprehensive list of alcohols and their compounds. There have been some papers published that say oh, this is the mass spec profile of bitters, but this isn't done for many alcohols. Or maybe it has been and it's just not available publicly. Anyways, there's a lot of room for expansion and improvement on the current iteration. And additionally, the idea of a cocktail graph is kind of fun, but there are also potential for applications in the food and health industry. Dietary restrictions are just one example, and the idea of being able to expand this graph beyond drinks is also a very ambitious and interesting idea. I want to give a shout out over to our collaborators, Hiren and Reese over at Zest, which is a food startup in the food and health space. We've had fruitful discussions, and I'm grateful for their advice on this project as well. Historically, I actually set out with the goal of building a food knowledge graph, but after literature search and a lot of brainstorming, the engineer in me decided to simplify and kind of take the simplest case of food, which is like a liquid, right? Like you don't have to include all the textures, like food kind of changes as you cook it. So I guess with that, I'd like to thank you for the opportunity to talk today, and I also want to thank my team for feedback and discussion. You'll hear Gunnar talk about his work on a cancer graph a little bit later today. Thanks for the Gracken community for always being super responsive on Discord, and thanks for all of the support. Thanks a lot, and I'm happy to take questions.
Well done, Justine. That is super interesting, and I'm glad that you mentioned the folks at Zest, because that was the first connection I thought of as I was listening to the back half of your presentation. This is great. So James asks, have you looked at writing rules to recommend cocktails based on ingredients you have?
Yeah, that's the next step. So I guess it took a long time to build the graph, and the next step is to write the rules. So that's kind of what we're working on now.
Very cool. And is there any opportunities for collaboration or contributions from the community?
Yeah, I certainly hope so. We're very open to collaborating. I guess all of this is in a private GitHub repo at the moment, but it's all based on open source data, and we're very much about sharing everything and making it accessible to everyone. So yeah.
Love it. And if they wanted to reach out, what's your Discord handle, or if there's another best place to reach out?
My Discord handle is, I think, @Justine. Otherwise, you can email me, justine@austincapitaldata.com. I can put that in the chat.
Excellent. Thank you. And then Gregor asks, have you tried to contact some like a local bar to use this in the moment, so to speak?
So this is kind of funny. I was actually a bartender for a little while. It's a little bit strange time right now because I don't know, I guess bars are open over in London, but like in California, at least in Berkeley where I am, bars are not open. So it's like, or you can't like hang out there and talk to people very much.
Right.
But that would be awesome. I can't wait till the day where I can walk into a bar and like talk about all of this.
Absolutely. And I would imagine there's a lot of folks maybe sitting at home saying, oh, I have some leftover fruits, I have some leftover ingredients. Maybe I need to pick up some new recipes.
Mm-hmm. Yeah.
So Hamad asks, can the exact ingredients be represented in the graphs as sub-branches of the substance that you're plotting?
Yeah, that's exactly how it is. So the relation between the ingredients and all of those compounds is the composition relation. And that relation, there's something over 8,000 different compounds which are in the graph at the moment, and the way that those are related to the ingredients is through that relation.
Excellent. Thank you for that that question. And then, oh, before I forget, there was someone that was looking for the link to that the webpage, CocktailDB.
Yes. I'll put that in the chat too.
Perfect. And then Gregor asks, did you try Leo's mixer from Leo Dictionary, or is the API less useful than your CocktailDB?
I haven't. Yeah, if you wouldn't mind sharing that, I would love to look at that as well.
Cool. Gregor, that's to you. Hamad, what is the, excuse me, Hamad asks, what is the database you mentioned in the beginning?
Which one, for the food or the cocktails?
Um, well, and you mentioned Cocktail DB, so maybe the food one.
Okay. Yeah, it's called Food DB. It's I'll put that in the chat as well. It's yeah, supported by the Canadian government.
Food DB.
Yeah.
Yep, Hamad, you're exactly right. And then RL asks, do you plan, or do you have a plan to make this an app or a product for all of us at home?
That's the dream. I think there's still a long way to go before getting there. I think currently the most like interactive part of it is a bokeh plot where it's all of the ingredients or all the cocktails are there. I think last you and where you can interact with it and scroll over it and see what the cocktails are. But then I guess there's still a jump between that and getting the ingredients and all the compounds and the recipes. Yeah,
Absolutely.
if you want to collaborate on building a front end, yeah.
Yeah, absolutely. Shouts to the community. If anybody wants to help Justine take this to the vision, make sure to reach out. One more question from James, and then if you have any additional resources to read up on your work, people would love to know that as well. But James asks, what parallels are you drawing between the chemistry of cocktails and your work in biochemistry more generally?
I think the connection is quite a loose one. Because like my work was studying like taste processing, so it's like a very basic science approach, like how are these neurons functioning, like what are they important for, and I think I guess the cocktails are more of like a holistic thing, right? When you have a cocktail, you have the sensory input, which is like what you're actually tasting, right? It might be sweet or kind of not salty, sour. But it's a whole experience of like, what do you feel when you drink a cocktail as well. But I think like being able to access all of the compounds inside your cocktail, if you're looking it up, kind of makes you feel a little bit like a chemist, right? You're like, okay, I'm making a martini, but actually there's like all these different compounds in it. So that's kind of fun.
Absolutely, and I would imagine that in some of the more serious bartenders out there, they might call themselves chemists.
Definitely. Yeah.
Justine, this was a really interesting project. Thank you so much for taking the time to share it with us. And as always, to the rest of the audience, if you have additional questions for Justine, do drop them into the Orbit channel in Discord, and that way we can continue the conversation there. And yes, I would imagine too that she makes a pretty perfect cocktail, Hamad. Although Justine, we'll have to wait until likely next year before we can be in the same city to prove that theory.
Looking forward to that.